Hi and welcome to another video, and I'm very happy to have with me today Maximo Balestrini, who has been one of the people really making these incredible 3D renders of the chips that we've been designing. And I met him early on in the Zero to ASIC course. He's got a company called Video Gamo. He's based in Argentina, and let's meet him now. How's it going, Maximo?
Hey, how are you? Good.
Yeah, good, thanks. I got all that right, did I?
Yeah,
Yeah,
you got it
yeah.
right. Yeah.
Cool. Okay, so why don't you just tell us a little bit about yourself? I think we actually already did a feedback interview for the course, but tell us a bit about your background that's kind of got you into the 3D graphics.
Um, I think my background in 3D graphic is it's about more about curiosity. I studied like software engineering, and I started working at banks and doing applications and things like that. But uh, with while I was working there, I noticed that I really enjoyed the visual stuff, and I like games. And so slowly I started transitioning and started working at interactive companies that do website or CDs or then games. And so my approach to 3D has always been like for doing curiosity to do some stuff. I've never worked in 3D particularly, but I made some games that use 3D and stuff.
Yeah. And anyone who's ever watched any of the videos on this channel will be familiar with your backgrounds. For example, the one with the lovely one that we've got around here now. And I'm just going to share my screen here because I just wanted to highlight some of my favorites. This is like an album that you very kindly shared with me, so that I can use. I think this was maybe one of the very first ones, which was for the first group submission that we did with Zero to ASIC course, with all the renders and then the active lines to activate each design. So not a 3D one, but then you did a lot of very cool 3D ones. With you did some really interesting kind of like curvy ones.
Yeah.
They were cool. I really like this one, like the kind of more abstracty ones. I like using them on my slide decks. That one's a really good one. You'll have seen them on my thumbnails. You did some where you were kind of highlighting individual nets, and you even did some animations. You did the animation for the flip-flop video that I did, with kind of showing how things turn on and off with time, like interfacing the Blender stuff that you do with spice simulations. You took some lovely photos of the MPW1 chips. You did some tiny tape out renders. You did a cool one of Uri's skull fets. Yeah, so much great stuff. This is one of the recent ones that you posted on Twitter. And every time people are seeing these great renders, they're always asking, how do I do it as well?
Mhm.
So we've been talking probably for 3 or 6 months about doing this video, but you're so busy. We finally got slotted it in, and we've got a little walkthrough guide Maximo is going to take you through. We've got a Git repository to share. So hopefully by the end of this video, you'll be able to take your design, take the work that Maximo's done, and put them together. So I think with that, I'll hand over to you, Maximo. We'll share your screen and
Great.
take it away.
Okay. Okay. Basically, the process I'm gonna show today, it's using converting the GDS file to some 3D format that Blender can import, and to then do the rendering. Normally the GDS files are just polygons, 2D polygons, informations on them, and you need to convert that to 3D and separate layers, give them layered heights and triangles. That's what normally the 3D programs use. So there's lots of ways in doing, I think, all this process. The Blender, this Blender version, I like it because it gives me flexibility to change things and try things. But there's also maybe probably some other like more automatic paths to do this. But you don't have the flexibility to change colors or do different stuff. So, okay. I have a folder right here with some GDS file. And the first thing we need to do is to download the script, that the Python script that transforms GDS files to STL files. It normally converts one GDS files in many STLs, one for each layer that you want to export. So we're gonna clone the story. Have it. Yes. All the instructions are going to be, the basic instructions are going to be on the repo. But we're going to clone this GDS to STL repo that I based on another on another person's project, but made some change to work with the Sky 130 layer stack. Okay, now we have the script. We're going to do some editing of the script. Right now, it doesn't have a lot of flexibility, so you have to. There's not many arguments or things like that. So you have to edit the script if you want to change some things. And what we want to do is change the layer stack. Here we are. Here's the layer stack definition for Sky 130, and it's the layer number and data type identified uniquely the layers. Here, the most common ones are already written when you download the repo. You can you can choose to ignore some layers if you want by just commenting the lines. This could be useful if you have huge, like real big GDS files that you that takes a lot of time to convert. So maybe you don't want all the poly or tabs or connections. And the other thing that you can change here in the layer stack, it's the layered base on the z-axis on the top, because on the GDS it's all just 2D polygons. So you have to decide the height of the layers and the position of the layers. Here you have also some flexibility. I like to use this version as it is, that uses like a bottom of 0 for Z and 0.1 for the maximum, the top, for all the layers. So when you run the script, all the layers were going to be in the same place, and then you have to use Blender to put them on whatever you want. And if you want to make it bigger, you can do it there. That's one way of doing it. And if you always do the same heights and whatever, you can change here the values and use the information. Here it is, for example, the layer stack from Skywater, and you can use these values, like, okay, we're gonna start local interconnect at 0.93 and it's gonna end on 1.37. No, sorry, it's got a 1.1 layer height. I sometimes use that option, but for this case, we're gonna leave it like this. Okay, and I'm gonna leave all the layers right now enabled because it's not a huge GDS file. So now I'm gonna run it. Okay. I'm gonna run the script with just the GDS file as the argument.
Hey, I just noticed as I'm following along that if you're doing this for the first time, you're going to need to do a pip install of the requirements that are also handily listed in the Git repo.
Yeah, you have to. I think on the instruction of the repo, I put it, but yes, you have to. There are some requirements, not a lot, but
yeah,
you need some files. Yeah. Okay, now we have the STL files, and we're gonna go to Blender. Using 2.9, but any new version will work also. So I'm gonna import the STL files. I'm gonna start with one as an example, and then we'll do more altogether. And I'm gonna start with substrate. I select the layer. I'm gonna leave this information as it is. I'm using one scale. I like that to understand a little bit about the scaling of how much it represents on Blender. What Blender calls a meter is going to be 1 micron because of how we exported the STL files. So now I'm here in Blender. I have the substrate layer. It's really thin. It's not. We're gonna see a lot right now. So what you should do when you import them, the layers. Here you have the list of layers on the right side. Here you have all the Blender options and panels and stuff. There's one that object properties, and here you can change the location and the rotation if you want it, and the scaling. I'm gonna create a material for each layer so that I can control the color and all the stuff that materials have. So here there's material properties panel, and I'll create a new one. I'll call it substrate. And I'm gonna choose some color right now, any color. It's not changing here right now. Blender has different viewing options. So if you want to like shade it a little bit, you can change it here. So now I have my substrate in red. I'm gonna import another layer. I'm gonna do it in order. So I'm gonna do. I'm not gonna import all of them. I'm gonna do diffusion. So now I have both of them. They are both on the same place right now. So if I try to see it from the side up, okay, they are both together. So now what I'm gonna do is change the position of the diffusion layer. I'm gonna put it just a little bit above the substrate so to be visible and not the not the top is coincident with the substrate. So I'm gonna be go to object properties and change the Z location. These values right now, as we import everything, will represent microns. So I'm just gonna put it a little bit above, and with that, I guarantee that it's gonna be always above substrate. Maybe a little bit. Okay, I'll do the same thing. I'll create a material for the diffusion layer. Need to put some color. Okay, and now I'm gonna import more layers altogether. We can do that. Gonna do local interconnect and metal 1 and metal 2. This also depends the time it takes to import them and all the how slow the interface becomes. It depends also on the size of the files. It's really hard, at least in my machine, to do a whole shell chip, all the layers. It's impossible, but I guess it depends on the machine and memory and stuff. So okay, now I have these 3 new
That's
layers.
actually a good question, if I can just interrupt you there.
Yep.
So, like, what machine are you working with? How much RAM? Like, is CPU important? Is RAM important? What are the guidelines?
I think it's both. Mainly CPU. It depends. I'm not an expert on Blender, so I'm not sure exactly how much does a good GPU helps. But this is an old book. It's a Ryzen Pro 7. I don't know the number exactly, with 32 gigs of RAM, gigs of RAM. Yes, and it handles the files well. But yes, obviously, if you have more memory or a better machine, you can handle bigger GDS files. But I don't have like a recommendation exactly of what type of machine you should have. Probably having a dedicated video card would also help
Cool.
on the renderings and stuff.
Okay, thanks.
Okay. Okay, now I'm gonna do the first. I'm gonna assign some material. This is metal interconnect. I'm gonna create metal 1 and metal 2. And I have to position them. And here you have again options depending on how do you want it to look. I'm gonna use I'm gonna separate them, the layers all by the same height, and I'm gonna use the same height for every layer. But I can show you a little bit of how to do, like, if you want to do it more similar to what the physical version is, you can change that. So okay, I'm selecting local interconnect, and I'm gonna position it 0.2 microns above substrate, or 2 microns absolutely. The substrate is at 0. So there, and I'm gonna do it the same thing. I'm gonna change metal 1.4, leaving like an empty layer, and same thing for metal 2. So now see a little bit. I'm gonna change the colors. Yeah. To make them visible. But okay, so I did this like they are the same height, but you can use again this information or to try to make them look like this. For example, if you wanna do something like that, you can look at where middle one is. It says it starts at 1.37. So you could here. I'm gonna go to middle one, object properties, and instead of 0.4, I could use 1.37. And to do the height of the layer, right now all the layers are 0.1 microns because that's what we set it on the export on the script. But for example, middle one is 0.36. So I can do that by scaling the layer 3.6 times what it had. So you can do that with all layers if you want to. You can properly set it at the proper height and at the proper position. It's a matter of what are you trying to achieve with the looks, or sometimes it's clear to have all the layers the same height because it's easier to see some stuff, and some other times you want it to be more like the real chip. Okay. Great. Now we have all the layers. We're gonna start editing the scene. First thing, I'm gonna change the Blender renderer. It has a couple of renderers, and the one that looks better is the one that's called Cycles. You can find it here in render properties. The default one is Eve, and we change it to Cycles. And you can have a preview of how the render will look if you, in the viewport, you change to this option of viewport shading. Okay, so right now everything is dark. There's just some light there, and for most of my renders, what I do is normally I delete this light, and I create an environmental map, sky. I do that by going to here, like the world properties of the scene, surface section, color. And if you click here, you can, instead of just using a color for the whole background environment, you can use textures and shaders and stuff. And there's the one I use normally is this one, the sky texture. And now you have, right now you have the illumination of the sky and the sun. You can see if I get closer on the viewport, you can see the shadow because it has the sun disk. You can take it out, and it will be more like cloudy, the scene. There are some parameters here you can play with, like the strength. Sometimes it's too much, it's too white, or so you can change it, like half the strength of the sun, or to give some climate, this air thing changes, like yellow one or more sunset or whatever. But you can play. It's interesting to play with this, like sun size, sun elevation, rotation. For example, elevation, there you have a sunset colors or lighting. But with that, you have like a cool scene without doing a lot of lighting stuff, extra lighting stuff. Okay, now we have the render. We can set the camera. Right now we're just looking at the viewport, but you have cameras in Blender. The first thing we're gonna do to easily set up the camera is gonna be like, okay, choosing a view, what you're viewing right now, for example, and you go to view, align view, and you align the camera to the active view, to what you're seeing right now. That would help setting up the first setup of the camera. Okay, and to move the camera, there are a lot of options. You can change. I'm gonna take the render stuff. You can move the camera. The camera it's there, but it's normally harder to move like that. The one thing that works is view, navigation, walk navigation, and so you can move it with your mouse and the keys, so you can like do some close-ups or going far away. If you want to change, like doing a top view, you can click on this gizmo. You look at the top of the chip, and then you do again the alignment of the camera to the view. Okay, now we're not seeing anything. That's another thing I wanted to show you, is that the camera has a clipping, near and far clipping, and because of the numbers we are using, the microns that in Blender we're treating them as meters, you cannot see past some numbers. So you select the camera, you go to the object camera properties, and then you have like the clip start, clip end for, and right now we're gonna change this 100 meter is 100 microns for us. So I'm gonna change it to 10,000. So now there's no, the clipping plane is behind the camera, behind the substrate. Okay. Okay, we could do some first render of this scene. It's easy. You just go to render image. Bring it here. It takes a while. One thing you can do when you're trying stuff is go to output properties here, and here you can choose the size of the render. It's like now it's HD, and so you can change the size in pixels here, or you can when you're doing some fast tests, you can say no, let's do half of this or the board. And so you can have, if you want to have an idea of the look of the scene or some change you did, it might help to do that. Okay. I'm thinking where to go. Okay. We're gonna change a little bit the camera again. Right now we're gonna do some material changing for the layers. We're gonna have a different view. I'm gonna align the camera to this new view. I'll enable the viewport like render, and now I'm gonna just show you a little bit of changing some properties of the materials of the layers. You choose one of the layers. We'll do metal 2.
Maximo, I think that the
material properties.
Your computer rendering is slowing down your computer, and I don't know. It might be your internet, but it could be also that the rendering
Okay.
process is killing your video stream.
Oh,
Did you hear any of
okay.
that?
Yeah, I hear it. Can you hear me?
Yeah, I can hear you. But for
Okay.
a while,
Oh,
all your video and your audio was stopped,
oh.
and as the computer was rendering. So it
Mm,
could be related or could be completely unrelated.
I okay. Okay. I'm gonna try to reduce the rendering, this viewport rendering precision to make it a little bit less heavy. So here in rendering options, you have the sampling options for the path tracer, and in the viewport I have 32 samples. I'm gonna do 16. That might help a little bit. Okay, I was changing the material properties of metal 2. There's a lot of play here, and I don't know if I have like special recommendations, but I normally have fun like changing things and trying and testing. But you have the base color. You can choose. Right now, you choose this red, but it has some specular lighting, so that's why you're not seeing it super red. You can change the specular reflections there, and now it's red, more red. And you can change if you wanted to have like a metallic look. I don't know if you're gonna see much here now, or the roughness of the material. Those are.
We're still waiting for the screen to catch up from the change on the red.
I'm gonna change some parameter to see if we can avoid these problems with the video, recording the video. I'm gonna use the GPU for rendering. That's an option you can try if you have a better GPU or CPU. You can do. I didn't have much. I didn't notice a lot of difference in my computer in rendering times, but it obviously depends a lot of each machine and GPU. So on the rendering options, you can choose the device, and you can choose GPU. So I'm gonna try right now if I enable again the viewport shading rendering. I can also reduce the size of the render. There. When you change to GPU, sometimes it takes a little bit more to start, but then it should be similar. So I was changing material properties. Let's see if I can continue doing that. I don't know if I think it's worse right now. At least for me, it's heavier. Okay. Okay, I was changing specular highlights to show you the difference in colors. I changed the transparency, the alpha value here, so that's why you see through it. I put it back there. That's no more transparent. Another interesting parameter you can change here is the emission. If you wanted to have like light that emits light, sometimes it depends on the scene, but you can reduce the environmental lighting and do some material emission here. You can achieve interesting stuff with that. And let me see if there is any other interesting one. No, the metallic properties are also good. We're not gonna see much now, but you can do it with some of the other. I'm gonna change all the other metal layers to some testing. I normally do this, like go back and forth and see if I like it, or choose the combination of colors, and I'll do the specular thing again, so it doesn't have all the highlights from the sun. Okay. Okay. We can keep changing a little bit of the materials. And choose the okay, now we choose, you can change the things for the camera, and go back again to change maybe things for the sky texture we were using, because that gives a certain feel or look to the scene, that changes how the materials look. And then we do again the rendering. I leave it. I left it with a small screen. Once the whole frame finishes, you have options here to save the file, whatever you want.
While it was rendering it, your audio clearly slowed down, so I think that's it.
Okay. I don't know if there's any way to fix it.
No, it's fine. This is all part of the process. Just if you're watching the video, just remember to don't do Blender renders when you're on Zoom calls with your colleagues. So
great. Okay, that is basically it. There's a lot of tweaking and trying different materials, maybe changing the layer heights if you want, or trying new position of the camera. Some other interesting tip that I gonna try to show, if the computer and the Zoom the connection allows me, is to use the depth of field effect of the camera. You can do that by selecting the camera, going to its properties, and you have an option here. It's like depth of field, and you have to choose the focus distance. You can use there's like a focus object. You can select the object, but here the layers are, as they're like a big object, it doesn't work very well. It's better to put the numbers here. And again, you're trying to think in that you're looking at microns, and it's a little bit of trial and error until you find a look that you like. But you have to change the distance and the aperture, the f-stop. You can choose some really small number to try to find where the focus is. Right now, you can see it's all blurry. Definitely, we're not focusing on exactly on what we're looking. So we can change, try to see if we get closer. You can probably look at where the camera position is and try to calculate the distance. We're getting closer. It's like 30 microns away, 40. I don't know if you're gonna see it a lot in the video, but now we see maybe this area is on focus and this is not. viewport rendering right now, it's not helping a lot because it all seems a little bit out of focus. But you can exaggerate a little bit the aperture again, half of that. I don't even know if it lets me. Yeah. Right now, this is a super shallow focus area, and we can see that we're just focusing on this area. We could do some rendering. I'm gonna stop the viewport rendering for having more computer power. Yeah, I'm gonna change the again the resolution to let's try 100% and see the look better in the image. Okay, I'm gonna stop it here, or we can see sometimes to use it.
Just wait for a minute, because as you were cancelling the job, we still couldn't hear you. So just repeat the last thing you said.
I don't know.
Yeah, cool. Okay.
Okay, I think that's basically it. That's the process roughly.
Excellent.
Really fast.
Yeah. So the other thing that you've done is you've got a demo repo, so we'll link that down in the description, and that's got some example GDS, the stuff that Maximo is going to show you. So if you don't have your own GDS, you can use that, and it's also got some Blender files that show some of his settings that he likes to get these cool results. Is there anything else you want to add about that repo?
No, there's also I'm finishing some walkthrough of the steps I take normally to do this rendering, but yes, and I was probably going to add some cool renders to show what you can do.
Nice. Cool. So I just wanted to get this up to show you that I've been following along in the as you've been doing it, and I've done my very first Blender render of the first GDS that I drew with some nice depth of field effects there. So thanks very much for showing us how. Great. And this has been one of the videos that has been most requested. So thanks again for your time in showing us how to do it. Really appreciate it.
Great.
Have a good rest of your day.
Okay, you too. Have a good night.
Cheers. Bye.
Cheers.